Hi everyone. So this is our last week on functions. So we today are going to talk about inverses. So let's start by finding f of g of x, g of f of x. So pause the video and do these on your own. So for f, I'm going to do f of equals the square root. All right, so I'm substituting in for x, g of x. So g of x. So that's x squared plus 9. If I simplify that, I just get the square root of x squared plus 4. You cannot take the square root of that. You are done. And then for the second one, g is the outside function, so something squared plus 9. Inside of that, we're going to put f of x. Remember the square root of a square and then a square, they don't technically completely undo each other when you're talking about functions. So we're going to put the absolute value of x minus 5 plus 9. And that's it. We're done. Okay, so let's go back to some vocabulary from Algebra 1. So let's see who remembers this. What is the additive identity? So an identity is something that doesn't change. So if you're adding, what will not change a number? 0. Right? So whenever you add 0 to something, if I have 5, I add 0 to it, it doesn't change it. So that's identity, when you're not changing a number. The inverse, what will bring you back to the identity? So what could I do to 5 to get to 0? -5. So that's the opposite. Oh no. Okay. How do I just move the rectangle? All right, I don't know what to do. All right, well, we're just going to move it all. All right, move that all. The negative of the number, it is the number that when added equals the identity. So the inverse doesn't change the number. I'm a disaster right now, guys. It doesn't change a number. The inverse brings you to the identity. Brings the number to the identity. So what will bring you to 0? Okay. All right. So now thinking the same idea, but with multiplication. What, when you multiply, does not change the number? Well, that's your 1. It doesn't change the number when you multiply. So what would be the inverse? What brings you, if you have the number 8, what will bring you to 1? That is the reciprocal. So 1 does not change the number. 8 times 1 equals 8. So 1 is my identity because it doesn't change it. What will bring you to 1? If I have the number 8, what will get me to go to 1? It's reciprocal, 1 over 8. So we're doing a review of that because now we're going to talk about the identity and the inverse of a function. So what function, when you plug in a number, you will get that exact same number out? So think about that for a second. If I have x equals 3, what function will give me 3? Well, that's just f of x that's just x, right? F of x equals x. F of 3 equals 3. F of 7 equals 7. So now what would be the inverse of a function? So when I plug into a function, I get x. So the question is, when I'm doing this, f of something equals x, right? I want to know, what can I plug in to f of x to bring me to x? So some function will give me x. So what would be the inverse? So f and g are inverses if when we do their composition, we get x out of it. We're plugging something into f to bring me to its identity, x. All right, so I want to plug in the inverse function is x. So 2 times what plus 8 equals x? That is the question. So I want to know what's this function g of x. So if I subtract 8 on both sides, just solving for x, and then divide by 2. So my inverse function is x minus 8 over 2. So if I go up here, I can actually show that. F of g of x, it's 2 times x minus 8 all over 2 plus 8. The 2's cancel. X minus 8 plus 8 is just x. So when we do a composition, we did the composition and we solved for the function that we're plugging in. Now, notice what we did here. What's another way of writing f of x? Y, right? So this is really y equals 2x plus 8, right? 2y plus 8 equals x. So look at what we did. Our original was 2x plus 8. In this line, what I actually ended up doing was making it 2y plus 8 equals x. So look at what I actually ended up doing. All I really did was switch my x value and my y value. And that's kind of the down and dirty way of finding the inverse of something. We switch our x and y and then just solve. So the inverse, so if I were finding the inverse of, if the inverse of f is g, then 1 brings me to 4, 4 brings me back to 1. 2 brings me to 5, 5 brings me back to 2, 3 brings me to 6, 6 brings me back to 3. So really, notice, we're switching our x and our y. If f is 1, 4, then its inverse is going to do the opposite. It's going to take that 4 and bring it back to 1. If my function 2 brings me to 5, then the 5 has to bring me back to 2. The 3 brings me to 6. The 6 has to bring me back to 3. And that's the only way, that's what functions are, right? And again, notice, this is x, y. All we're doing is reversing our x and our y. So to find the inverse of a function, reverse the x and y values in the function and then solve. And that's just coming from the fact that f of g of x has to equal x. That's like your definition of what an inverse is. When you do their composition, you get x out of it. This is our y, right? So we end up switching our x's and our y's. All right, so these are really not that hard, especially with the linear ones. So I'm going to start by replacing f of x with y because it's weird. I'm going to switch my x's and my y's. So x equals 3y plus 9. And I'm just going to solve for y. So subtract 9 on both sides. Divide by 3. And that's our g of x. That's our inverse. X minus 9 all over 3. If you want to write it 1/3 x minus 3, you can. You don't have to. All right, let's try the next one. Again, I'm going to get rid of my g and I'm going to write a y to start with. I'm switching my x and my y. That's the starting point of finding my inverse. And to solve for y, we square both sides. X squared equals y minus 4. So y equals x squared plus 4. So g of x is my function. I'm going to call f of x its inverse. And we are finished. All right, pause the video and try number 4 and 5 on your own. 5 is a little more difficult. So y equals negative 2 over 5x plus 7. I'm going to switch my x and y. Oops, I forgot to write y. I always do that. I always do the highlighter instead. Alright, so I'm going to subtract 7. So negative 2 over 5y equals x minus 7. Multiply by the reciprocal. Negative 5 over 2, x minus 7. Done. Alright, so we have y equals 2 over x minus 4. That's the original. Switch my x and y. X equals 2 over y minus 4. There's a few ways to do this. The way I do it is I cross multiply. I'm going to put x over 1. Multiply on the diagonal. So 2 equals x times y minus 4. Now there's two ways to do this. I'll show you the distributing way. So if you distribute, 2 equals xy minus 4x. So remember we're solving for y. Xy equals 2 plus 4x. So y equals, what's x? 2 plus 4x all over x. And that would be your answer. The other way to do it is at this point, divide by x. So I would do 2 over x equals y minus 4. And then add 4 to both sides. Those are the same exact problem. If you just divide the red, both of these by x, you get this. Either way works. Alright. Pause the video. What do you think? So the inverse, we're going to call the inverse g. So all I'm doing is reversing. 2, negative 7. 1, 8, 0, 4, negative 6, 2, and 17, negative 8. That's it. You honestly can't get much easier than that, right? Let's do this one. So just pause the video, reverse it, what happens? 4, 1, negative 5, 3, 6, 8, negative 5, negative 3, and 0, negative 2. Alright, now, there's an issue with this one. Look really close. What's the problem here? This is not a function. Look at this. So the function is not, the inverse is not a function. Why did that happen? Because you have the 3 mapping to negative 5 and negative 3 mapping to negative 5. So remember when we learned about our rules about what a function is, 2 x's, can go to the same y. When you have an inverse, that's not allowed. You can't go backward. You can't go backwards. So this is called one-to-one. We're going to get more into that tomorrow, but just notice that if you have the y's repeat, it's actually the inverse is not going to be a function. And we're going to have a whole nother issue there. All right, last one. Graph the inverse. So the easiest way to graph the inverse, especially if it's not something you know about, what I do is I just write down points. So this actually, if you notice, this is half of a parabola. So I have 0, 0, 1, 1, 2, 4. So my inverse, 0, 0, 1, 1. And then this one we're reversing it, 4, 2. So I'm going to plot those. 0, 0, 1, 1, 4, 2 doesn't quite fit, but we're going to make it fit. And that's the inverse function. That one's kind of silly because we kind of knew what it was going to look like. All right. So for this one, I'm gonna write down some of my points. I would add into here like this one and this one. I'm gonna add some points in there. So I've got -3, -1, -1, 1, 1, 1, and 2, 4. So I'm gonna take those. I'm gonna reverse them to find the inverse. All right, so I'm going to do this. I'll do it in black. All right, so I have -1, -3, 1, -1, 1, 1 did not change, and then 4, 2. So this looks like this. So that is your inverse function on the graph. All right. All right, we're going to get a little more into more detail into this on Wednesday. This was kind of just our introduction lesson. All right, homework 86. I will see you guys tomorrow during our Google Meet. Have a great day.